welcome to another tutorial with the Learn It channel teaching Fusion 360. Hope that you like that little introduction. Please know that these take a long time to produce, so if you find these tutorials beneficial, please like and subscribe. It would mean a lot to us. Well, let's dig into it. So today you are going to learn a ton about drawings, let's look at our timeline, about extruding, filleting, holes, sketches, and again, assembling. Besides that, you're going to learn something amazing about creating these screws. You might think they're the hardest thing on this project, but they're actually the easiest. So let's get into it. The first thing that we're going to do is take a look at our drawings. Here we have our assembly drawing. We have a box, lid, and screws. Our box and lid are aluminum, 6061, and our screws are made of steel. Then we have our box drawing, our lid drawing, and our screws drawing. Again, if you are new to learning Fusion 360, try not to start at this tutorial. Go back in the playlist, try and look at some tutorials that talk about an introduction to sketching. You can find one here on the top of the screen. But if you have gone through all of our tutorials and are now at this point, well then let's dig into it. So let's create a new project first of all, or a new design. So remember, we have 3 different types of components in our assembly. So the first thing we're going to do is let's save. And we're just going to call this box assembly. And let's save. So we have 3 different components. Let's create them right from the get-go. If we know how many components we're going to make, let's start with that. So we're going to right click here or go to our create menu, and new component is right there. Let's create our first one called box. I'm just going to right click, new component. We're going to call this lid. We're going to right click and call our third component screws. There we go. So we have box, lid, screws. Please note this, everyone. Right now, because we've just created screws, we have activated the component. It's this little eye or little bullseye off to the right. If we wanted to activate lid, well, we hover over it and we activate lid. Box, we do the same thing. Because we're going to start off with our box, let's activate that. So let's go to our box drawing. Here we have it. Let's take a look at our main dimensions first of all. So here we have 8-inch width by 4-inch depth by 2-inch height. What else do we have? Well, we have a 1/2-inch typical radius on the outside. So obviously there's going to be 4. And then we have a 0.1 typical radius on the inside. That not only does these 4 inside edges, but also these ones on the bottom. You can see that with our model off to the side here. Our wall thickness, it's 0.4. Down here is also 0.4. And then we have our spacing of our holes, our tapped holes, in both directions. Perfect. So now we can get started. Let's start off with the simplest one, is our 8-inch width, our 4-inch depth, and 2-inch height. So there are many ways of doing this. We've already talked about in previous tutorials doing a box. But today we're going to focus on sketching because you're going to learn a new skill. So let's do it. So let's select our XY axis. We're going to create our center rectangle. And remember, we can move our mouse cursor to any quadrant, and our dimensions are always based on the same distance from our center point outwards. So we can go to any quadrant, doesn't really matter. So our depth here is 4 inches. Press tab and go to 8 inches for our width and hit enter. Just hit enter once. If we hit enter twice, it will finish our sketch. Now we want to put fillets or rads on the corners of our part. So when we click fillet, we're going to pick all of our edges in sequence. We don't want to do one and then type in our dimension and hit enter, because then we have to do that for every edge. It takes a long time. So let's undo that. Let's go back to fillet, and we're going to pick 1, 2. Don't worry about the dimension. 3, 4, 5, 6, 7, 8. Now type in your dimension and see what happens. There we go. All of them are the same. Why? Well, you'll see that the little equal sign here is on all of them. That means that all of them are equal to each other. The radius value is equal to each other. Great. Now we have the wall thickness, which is 400 thou. So again, there's many different ways of doing this. However, let's take a shortcut. Let's go to the offset sketch feature here. The shortcut key is O. Let's press O. And we're just going to pick our sketch. And look at what we can do here. It just so happens that because it's 400 thou thickness of our wall, that the rads here will mathematically correspond to 0.5 minus 0.4 equals 0.1, which was in our drawing. So let's make our wall thickness 0.4 inches. So here we have it, 0.4 all the way around. If we're unsure about this radius value, well, let's go inspect and select it. And here's our radius, 0.1. So we've proven that it is right. Again, there are better ways of doing this, but this tutorial is showing you how to use a new feature of sketches. With every tutorial, you will continue to improve with your sketches, which is fundamental to be a good draftsman, a good modeler. So we have the basis of our sketch. It looks great. Let's finish it. Now we're going to extrude. Let's extrude it. Press E for extrude. We're going to pick our outside profile. And remember how tall it was? 2 inches. So let's type in 2. Now, what about our bottom? We also wanted to extrude that, and our drawing said it was 400 thou. Let's go back to it. Right here, 400 thou thick. So in order to do that, we can just go back to our sketch. If we want to find it in our browser, we just click on our timeline. There's our sketch right there. We can find it in our box under sketches. It's right there. Perfect. So as we click on the timeline, you can see our sketches folder will have this dashed line under it. That's showing that our sketch feature is under that particular folder. So now that we have it activated, we can press E for extrude, and we can pick that inside surface. Let's bring it up. Oh, 0.4. 0.4. There we go. Remember to hide our sketch after by hiding it. Great. If we wanted to just prove that this depth between this face and the bottom face is 400 thou, let's click on our measure, click that face and the bottom, and here we have our distance, 0.4. There's an even easier way. Let's click on it, and on a Windows computer, press Control, on a Mac, press Command. Press Command and select the bottom one, and look what we have down here. 2 faces, minimum distance, 0.4. Great. Now we want to create the holes for our tapped hole location. So let's go back here to drawing. And if we zoom in, we have our distance, 3.424, 7.424. So let's create that. We're going to create a sketch on our top face now. Our bullseye is in the middle because we're building our part around our bullseye, our origin point. Let's go to 2-point rectangle, select center. And we're going to move this out to approximate the location we are, because I've forgotten the dimensions already. So let's go finish sketch. We'll go back to our dimensions, 7.424 and 3.424. So let's remember 424, 424, and the rest is easy. Let's go back to our sketch, and we're going to dimension this now. 7.424, enter, and dimension this one, 3.424. Beautiful. So now our endpoints here, our vertices, are perfectly in line to make our holes. Let's go finish sketch. Let's go back to our drawing and look at our hole dimension. So here it is. We have 4 times, or 4 holes. This is the diameter. It goes 1 inch deep. But it actually shows a classification here, 1024 UNC 2B. What does this mean? Well, remember, we are putting screws into these holes. So this is actually a tap hole that we're going to create. We're going to create a female thread. 10 is the wire size, or the gauge of our tapped hole. 24 is our number of threads per inch. And this is a classification UNC, which is unified, coarse, 2B. Now that's a lot to take in, but that's going to come back to help us in the future. So let's just remember this for now. 10-24 UNC and 1 inch deep. Let's go back. We're going to create a hole now, and let's pick each of those points. 1, 2, 3, 4. So clearly our holes are gigantic right now. They're 2 inches in diameter, but that's okay. We've just picked the reference points. Now what do we want to do? Let's go to hole type. We want simple. But now hole tap type. Let's go to tapped. Now we've got an extra little bit of information on our dialog box that we can choose from. So our depth, do you remember how deep it was? Our drawing said 1 inch. Now what about our thread type? So we're in unified. That's great. Let's go to our size now. We're going to go all the way up to number 10. We have 1024 UNC. That's exactly what we've wanted from the drawing, and our class is 2B. So if we zoom in all the way here, you can see that there is a basic, simple model of our thread. Now, if we scroll down in our window, we can see that there's a selection for modeled. Let's click that. And now we've got the very complex modeled shape that goes all the way down to the bottom, the whole depth. Why do we want to select that? Well, if we're doing 3D printing, we want this to be 3D printed. We want it to follow that profile, so we would go modeled. In our case, we want to deselect it. Well, why? Because as we deselect our model option here, all it does is keep a perfect circle that we can pick later on, which we will need to do to create our counterbores in our lid. So let's leave that off for now. Let's hit OK. It gets rid of our sketch. So here is our box. It is finished. That's great. Now what do we do? Well, the next part of our lesson is going to talk about in-context design. So what does that mean? Well, it means that instead of creating our lid with its own dimensions, creating everything from scratch from our own sketch, we are going to create our lid based off of our box right here. This is an awesome feature of Fusion 360. So let's activate our lid. If we don't, we're in big trouble. So please remember to activate our lid. What happens? Our part becomes transparent. Our box becomes transparent. That is perfect. That's exactly what we want it to do. It's saying that we don't have our box activated. We have another component activated, which is our lid, but we can still use this geometry to create our lid dimensions. So now let's go to our lid drawing. We can see that our lid is 8 inches wide by 4 inches deep. Its height is 0.525 from top to bottom, and it's got a little lip on the inside, 0.125. That little lip is also 400 thou wall thickness, or away from the wall extent. And then we notice that our holes are in the exact same position. Our radius, our fillet, is exactly 0.5, and our inside radiuses or fillets are 0.1. So this is telling us that all of the rads and the fillets are exactly the same. The depth and the width are exactly the same. The hole locations are exactly the same. Now, it doesn't specify the counterbore information. We're going to create a standard counterbore for a socket head cap screw, and that's based on our screw drawing. So let's first of all draw our lid. Let's remember just these two dimensions, 0.525, 0.125. Let's go back to our box assembly. Let's create a sketch. Remember to activate our lid first. And here we're going to pick not one of our major planes. We're going to pick our top face. Now this might be hard for our eyes at first to adjust to. So just remember, as we hover our mouse over, you can see that the planes change a little bit. So just make sure to pick our top face. And here I'm selecting in between those two lines. And guess what? We don't have to dimension anything. By selecting a sketch on any face, we can see that all the geometry is inherited. This is amazing. Now we can extrude any of this geometry, just like we've already drawn everything. So let's extrude. We're going to extrude both profiles, and we're going to go up to 0.525 minus 0.125, which equals 0.4. That's right. So look at this. We've got our perfect lid so far. But we see one issue. We've actually extruded these holes. We don't want to extrude them. We actually want to keep this lid solid. So let's go back to our extrude. And with our profiles, we're going to hold down Command on a Mac, Control on a Windows computer, and pick our hole locations as well. 1, 2, 3, 4. And now look at our lid. It's completely solid with no hole locations. Now what about the underside, the little lip on the underside of our lid? Well, let's hide our box now. How do we get that sketch back, the profile of the inside of our box? Well, we open up our lid, we expand sketches and turn that on, and look what we have here. We've got the profile for the inside of our box. Let's extrude that. And remember this dimension? We bring it back, minus 0.125 according to our drawing. So now we've got this little lip that will perfectly fit and mate to our box. But what about our counterbore holes on the top of our lid? How do we find that dimension, or how do we project those center points of those holes, those tapped holes, onto the top of our lid? Well, we are going to go back to our sketch. We still got sketch activated here. We are going to create a new sketch on our top. And now look what we're going to do. We're going to flip the part around and press P to project. And we're going to take that hole, that hole, that hole, and that hole. And when I say hole, it's actually the circles that are left over from our previous sketch. And look what happens. On the top of our face now, we have 4 points. This actually projected the entire circle. So we can remove that. and we can select just the center point. Oh, there we go. So now we've got 4 points to work with. Let's finish our sketch. And now let's create a hole. Let's pick those 4 points again. And it automatically defaults to what we had just created, which is our tapped hole. But now we want to create a counterbore and a hole tap type. We want to create clearance. Now we can input our information. Our standard is going to be the same screw or the same tapped holes that we just created. Let's go unified screw threads. Fastener type is going to be socket head cap screw. The size is going to be a number 10. Fit normal. And look at what we have here. It automatically creates our socket head cap screw counter bores. Let's go OK. Just remember here too that we want a socket head cap screw. Let's go OK. How do we know? Well, we can go back to our screws drawing, and here we have a Torx alloy steel socket head screw, number 10 by 24 by 1 inch. So when we go back to our lid, believe it or not, our lid is completely finished. Let's activate our box again. And in fact, right now, let's go to our entire assembly and activate it. And you see what happens. Everything under the box assembly profile is now solid. It's no longer transparent. So here's one problem. We actually have to learn this in this tutorial too, is we have to learn all about joints. So let's just click our lid and move it off to the side. Oh no, now they're separated. Well, that's okay. This is actually designed in Fusion 360 to happen. What is a joint? Well, it takes two components and easily joins them together. So first and foremost, we want to take our box here and we want to make it stationary. We don't want to also move this box. So how do we do that? Let's go undo. We're going to right click on box and click this ground. There we go. So now no matter how much I click, I cannot drag it. But our lid still can move. Here's an introductory to joints. We're going to scroll over joints here and see what it says. Position components relative to each other in an assembly, then defines the relative motion between them. So let's click this icon or J. And you have to remember this fundamental instruction for Fusion 360. To join something, we always have to click this to that, this to that. So we want to move this to that. And in fact, Fusion knows this. We've already grounded our box. We cannot move our box over to another location because it's grounded. So we can only move, at this point, our lid to our box. So we actually want to mate this surface to this surface. Well, how do we do that? You can see here, as I hover my mouse over this face, there are so many different points that come up, and these are little snap points. As I bring my mouse along to them, they snap into location. I can actually pick this face as well. I can pick this face, and you see all these different snap points. They all have meanings as well. We have a little point. We have our triangle, which is our midpoint. Our square, which is the dead center of each individual face. So we want to click on this face. And when we do, we can now click on the center point of that face. If we don't, look at what happens. I'm going to go back to joint. If I try and select the middle, you see it actually changes to the other face. Well, I want the center of this face. So how do I get to that center point? Remember, I can click on the face, and then it will allow me to select the center point, or you can hold Control on a Windows computer, Command on a Mac. You can do the exact same thing. Now look what happens. Our box is activated, and now we can select the center point of that face. So let's do the same thing. I'm just going to click on that face now, and I can pick the center point. Look what happens with our joint. Hey, our lid fits perfectly onto our box. That is great. Let's press OK. Remember, we can hide joints. We can hide any feature by clicking on them and pressing V. Okay, so now we have our lid, we have our box, but now we need to insert our screws. So remember, this is the easiest part of this entire tutorial. First of all, we are going to activate our screws component. Now let's look at our screws drawing one more time. Here we have McMaster part number 92610A247. It's the Torx alloy steel socket head screw, number 1024 by 1 inch long. So because this drawing actually helps us in an incredible way, it shows us that McMaster has a part, here it is, and it's exactly what we see on the screen. So you thought we had to model this screw? Not yet. We're not at that level yet with our skills, but we are at the level of learning all about McMaster. So let's just copy this number, go close, and go back to our box assembly. Make sure that our screws component is activated. And now let's go insert and look at what we have. McMaster car component. McMaster is an amazing company that has a huge catalog of everything you could ever imagine, from motors to pistons to screws, washers, anything and everything in between. Let's click on it. Remember, we have our part number, so we can go to the search dialog and just paste into our search. We could also search for it by going into screws and bolts, looking at our thread size, 1024, scrolling down to our length, 1 inch. We can look at our head type, which is socket. And there we go. We have alloy steel socket head screws. But let's just put in our part number. There we go. It's found it. It brings up a little window, and it's saying, look at what we can do. We can download a 3D file. So let's click on that, and let's download step. Download. Well, look at what we have here. We have a screw in the middle of our part. This is great. Let's just move it up and go OK. Now, we don't want 1 screw. We want 4 screws. So let's right-click that screw, copy, and paste it. Now, because we've moved the screw up, it's saying, well, some component positions have changed. Do you want to capture it in its current position, or do you want to revert back to the previous one? Well, what happens when we go capture? You see it actually puts another feature in our timeline. So sometimes we want to capture it, sometimes we don't. If we capture everything, we're going to have a million captures in our timeline, and some of them don't really matter. So in this instance, we've just brought it up for your sake so that the screw is not lying in the middle of the box. But in reality, I would probably have gone revert and finished my part with the screws all in the inside. But let's just select here, and we've pasted it at the exact same location. Now we can actually select these two by pressing Shift. So let's click the first one, Shift, click the second, right click, copy, and we're going to paste it there too. And we're going to go OK. So we actually have 4 screws, and they're all on top of each other right now. If we expand our browser, Look at how smart Fusion is. It actually numbers them 1 to 4. So let's hide 3 of them. And now with our joints, we are going to join this screw to our counterbore. So let's do that. Let's zoom in. Remember the formula for joints? This to that, this to that. So joint. Remember, same thing with our lid. We're going to pick our face here, and then we can pick the center point. Now we want to move it to that. Let's just pick any of our counterbore holes, do the same thing. Click on our face, click on our center point. And look at that. Our screw is perfectly inserted. Remember, our tapped hole was 1 inch depth there, and our screw is 1 inch. But because the lid has a height, it's not going to hit the bottom of our tapped hole. So that's perfect. Let's go OK. Let's view our second screw and do the exact same thing. Now our third screw. And our last one. Well, would you believe it? We have finished our part. We have learned an absolute ton in this project today. What did we learn again? Well, let's go back to our assembly, activate it, and we can see that we created components, we did sketches, we created a tapped hole for the first time, we created an InDesign process as well. We created counterbore holes. We learned how to pin our major component, our main component, so it doesn't move. And then we started joining the lid, imported our McMaster screws, and then jointed all of them to our box. So this is amazing. Fusion does so much to help us to build exactly what we have in our imagination, in our mind. And with McMaster, I encourage you to go look at all of the amazing things that are found in the catalog. Here we have U-bolts, nails, staplers, key stock, tape, welders. They have so much that you can input into your design and utilize with future projects. So again, if you've benefited from this tutorial at all, give it a thumbs up. Tell us anything else that you'd like to learn in the future. Subscribe to the channel too for more updates in the future. And please accept our wholehearted thanks for joining the Learn It channel. See you again with our next tutorial.